Hi, today we are going to discuss about collision resolution techniques in hashing. So, first of all, we should know what is hashing, what is meant by collision, and how to handle problems of collision and what are collision resolution techniques. First of all, what is hashing? Hashing is a technique used in data structures that efficiently stores and retrieves data in a way that allows for quick access. Hash table is used to store data. So there is a hash table. Hash function is used to create index. There is a hash function. Data is fed as input to hash function and it generates index to store data in hash table. We can insert or retrieve data in order of one time using hashing. Say, here we have some keys. I wanted to store these keys in the hash table. So these keys fed to hash function as input. So this hash function generates index to store the data in the hash table. So this is the data and the data is to be stored in hash table in a proper location. So hash function detects some index. So in this particular index, the data is going to be placed. There are four data items. The four data items have been stored in the hash table. Then what is collision in hashing? What is collision in hashing? Collision. It is a situation in which hash function returns the same hash key or index for more than one record or one value. It is called collision. Sometimes, when we are going to resolve the collision, it may lead to overflow condition, and this overflow and collision condition makes poor hash function. For example, there is a hash table. In this hash table, there is a possibility of storing 5 elements. So, size of hash table is 5. Size is 5. 5 elements we can store in the hash table. What are the values we are going to store? Say, let us have these two values. Try to store these two values in the hash table. Then, to store a value, we find index. We find index using hash function. Using hash function. So, this hash function, for example, here we are using division method. Division method. Division method means the data is going to be divided with size. Data percentage size. Data is 10, percentage 5. Percentage means it gives you remainder 10 percentage 5 which gives you 0. In the place of 0, say this is index. In the place of 0, we are going to store our 10. 10 is stored at location 0. Then try to store second item 15. Again, you wanted to store 15, you need to find index. How to find index? Using hash function. Data is 15 divided by size divided by 5, 15 by 5, 3 and remainder is 0. 0 is your index and in the position of 0, there is a possibility of storing only one value. That value is filled 10 and now there is no place to store 15. So, which is said to be collision. So we wanted to store one more value where and already one value has been stored. So there is no place. There is no place to store 15. That's why it lead to a problem called collision. Right? Collision. How to resolve this collision? How to resolve this collision? Collision resolution techniques. Collision resolution techniques. If collision occurs, means if we get the same index for more than one value, which is nothing but collision. If we got collision, we can resolve this collision using collision resolution techniques. They are separate chaining, open addressing. There are two techniques, separate chaining and open addressing. Again, open addressing is having some sub methods, which is linear probing, quadratic probing, and double hashing. So, collision resolution techniques, separate chaining, open addressing. Open addressing is again divided into linear probing, quadratic probing, and double hashing. Let me explain this one by one. Let me explain separate chaining collision resolution technique. Separate chaining is a method in which additional field with the data that is chain is introduced like a linked list. A chain is maintained at the home bucket. When collision occurs, node is added to the linked list. For example, let us consider a hash table of size 10. So there is a hash table, the size is 10. We apply hash function, so division method, key percentage size of table. Let us take the keys to be inserted are 31, 33, 77, 61. So this is a separate chaining method and we are applying division method. That is, when you apply 31 to hash function of 31, it has to give you index. So 31 percentage 10 size of table 10, so it is 1, the index is 1. In the place of 1 we have to place our 31, but it is used as a linked list concept. So it generates a node with information 31 and it adds to bucket 1. So at 1, at index 1, it creates one node and adds that node at 1. Then for example another value 33. So again, try to add another value to the hash table. Hash 33, it generates index. What is the index? 33 percentage 10, 3. It has to place 33 at location 3. At location 3. So at location 3, it creates a node 33 and adds it to that particular location. Then if it wanted to add 77, create index 77 percentage 10 by 10 is size, 77 percentage 10, it creates 7. 7 is the index. At 7 you are going to add a new node with information 77, then 61. So 61 percentage 10, hash function generates 1 where 1 1 is already having one node. Here there is no limit in adding nodes. So create a node with information 61, add it to 31 so that this particular location is having two nodes. So bucket 1 is having two values, bucket 3 is having one value, bucket 7 is having one value. Suppose if you wanted to add 84, 84 percentage 10, you will get 4. So at 4, you will going to add node 84. Suppose you wanted to add 55 percentage 10, you will get 5. Is there 5? Yes, 5 location is there. Going to add a node with information 55 and that is added at 5. Suppose you wanted to add 91, 91 percentage 10, you will get index 1. So you have to add this 91 at bucket 1. So it creates a new node with 91, and that 91 is the previous already existing linked list at the last position. So bucket 1 contains three values 31, 61, 91. So there is no limit. No limit. If it is just an array, there will be a limit of storage. But if you use a linked list, there is no limit. You can add any number of nodes to the list. Using if you use linked list. Open addressing. Open addressing is a collision resolution technique in hash tables where all elements are stored directly within the hash table array itself rather than using external data structures like linked lists. In the previous case in chaining where we are creating new node and we are adding that node at the required or specified location. Suppose if the bucket is 1, the new node is added to bucket 1. Suppose again you wanted to add one more node. Node is created. Storage space is allocated, extra storage space is allocated, and it is added to already existing linked list. So there we need to create much more memory, but in here in open addressing, whatever the table that is created, say there is a table, some storage is created or allocated, reserved. So only the storage is going to be used. 0, 1, 2, 3, 4, 5, 6. Say this is hash table. Only this storage data is going to be used to store values, and we are not going to create any external nodes or going to link any external links to the data that is there hash table. When a collision occurs, meaning two keys hash to the same index, the method probes through alternative vacant slots in the table according to specific sequence until an empty spot is found. There are three methods in open addressing. They are linear probing, quadratic probing, and double hashing. Open addressing means whatever the space that is allocated as hash table, only the space is used even there is collation. Even there is collation, right? The first method in open addressing is linear probing. Linear probing is a very easy and simple method to resolve or to handle the collision. In this, collision can be solved by placing the second record linearly down whenever the empty place is found. For example, let us consider a hash table of size 10. Say there are 10 data items we can store. So there is a table which can store 10 data items, and we are going to use a hash function using division method. Using division method, see key percentage size, key percentage table size, hash function hash key is equal to key percentage table size, which is division method. Using division method, we are going to find index. Consider the following keys to be inserted. What are the keys? 56, 64, 36, 71. First, let us take 56. 56 percentage 10. Table size is 10. Size is 10. So 56 percentage 10. Hash function generates index 6. So 6 is your index. 6 is your index. So in the place of 6, 56 is placed in the table. Right. The second one is 64. 64 percentage 10. Find the index by using hash function 64 percentage 10. You get 4. Check 4. Yes, it is null. So in the place of 4, 64 is placed. So in a table where there is a possibility of storing 10 data items, we have stored 2 data items. Now try to store next item 36. So read 36 and try to store 36. To store 36, find the index using division method. 36 percentage size of table. So 36 percentage 10 is 6. C6 already filled with 56. So collision occurred. So to store 36, where there is a possibility of storing 36 in location 6, but sixth location is already filled with 56. So there is no place directly to store 36. So we try to store 36 in the next possible location. In the next possible location, say 6, the location is 6. The next possible location is 6 plus 1, 7. Is 7 free? Yes, 7 is free. So if 7 is free, so there is no element already stored. So let us store our next 36 in the next possible location. That is said to be linear probing in the down the line, the next possible location. If there is any element possible, if there is any position is vacant, then that particular vacation can be filled with this value. Right. Now try to store 71, fourth one. Try to store 71. So to store 71, again find index. How to find index? by using hash function. How to find the index? Hash function is variable or value percentage size. Value percentage size gives you index. Index is 1. In the place of 1, you place 71. So 1 not filled with any value, so 71 is placed in 1. So here in this way these four elements have been filled. Suppose if I wanted to store 46, if I wanted to store 46, so 46, find the index 46 percentage 10, you will get 6. See 6, yes, it is already filled, already filled. So next location, is there any other location? Is there any is there possibility of storing the next location? No, next location is already filled. So 6 plus 1, 7. 7 is already filled. So next location, try to find, check the next location. 7 plus 1, 8. Is eighth location filled? No, it is null. So you can use this location to store 71. So 71 can be placed in the next possible location. Suppose you wanted to store 91. For example, I wanted to store 91. 91. Find the index 91 percentage 10. You'll get 1. So 1 is the index to be stored. 91. Check 1. It is already filled. Collision occurred. So when collision occurred, using linear probing, we are going to store the element in the next possible location. So 1 plus 1. Check the next possible location. 1 plus 1, 2. Is 2, is there is a possibility of storing 2 in storing our 91 in the position 2? Yes, 2. 2 is vacant. Null is there. So in the position of 2, you can place 91. So in this way, linear probing means if collision occurred, it checks whether the next possible location, whether it is possible to store a value or not. If it is not possible, again the next possible location. So if it is 6, if collision occurred at 6, so it checks 7. Is 7 vacant? If 7 is vacant, you can place your data at 7 location. If 7 is not vacant, next possible location will be 8. Is 8 vacant? If 8 is vacant, you can place your data at 8. Like this, it checks. It checks and places the data. So it is not going to create any extra memory or any linear linked list. So it is said to be open addressing with linear probing. Quadratic probing. Quadratic probing is an open addressing collision resolution technique in hash tables that eliminates primary clustering by using a quadratic polynomial I into I or I square to find the next available slot. When a hash collision occurs, it checks slots 1 into 1, 2 into 2, 3 into 3, etc. So hash key is hash key plus x into x percentage table size. If collision occurs, we use this function. Generally, we use division method. Division method. Division method means the key is divided by size of the table. Say, if I wanted to store 67, 90, 55, 17, 49. So initially, say 67 percentage 10, which gives you 7. Is 7 free? Yes. So 7 is free. So 67 is placed at location 7. There is no collision. Then try to store 90. 90 percentage 10. You will get 0. So 0 is your index. Is 0 free? Yes. So 0 is free. 0 is placed in 90 is placed in location 0. Then 55. 55 percentage 10. You will get 5. You will get 5. 5 as index. So index 5. 5 is location. 5 is filled with 55. No issue. Then 17. 17 percentage 10. 17 to store 17. Again we use division method. 17 percentage 10. You will get 7. But 7 is already filled with 67. 7 is already filled with 67. So it is not possible to store in location 7. So 7 to insert 17, the initial index generated is 7. So 7 is already filled with 67. So collision occurred. Now we apply this function, quadratic probing function, that is hash key. Hash key is 7 plus 0 into 0 percentage 10, which is 7 percentage 7 plus 0. Yes, 7, 7 percentage 10, 7. Not possible. So 7 is failed. And again, you are going to use the next possible location, 7 plus 1 into 1. Now it is 1 square. I square. I may be 0, I may be 1, I may be 2, I may be 3, I may be 4, etc. So 0 is not possible. Now try with 1. 7 plus 1 into 1. 7 plus 1. Percentage size is 10. 7 plus 1, 8. 8 percentage 10, which is 8. Is 8th location free? Yes, it is empty. So 8th location is filled with 17. Now try to add one more data item, 49. So 49 percentage 10, which is 9. 9 is your index. Is there any location? Say here 17 is filled. So 9 is, yes, it is free. So in the place of 9, you can place your 49. 9 is placed in 49. Suppose if it is 80, if I wanted to store 80, 80 percentage 10, which is 0. So 0 is already having value 90. So it is not possible to store 80 in the place of location 0. Collision occurred. So to resolve this, we use quadratic probing. Quadratic probing means 0 plus 0 into 0 percentage 10, which is 0 only. So not possible. So try with the next location, 0 plus 1 into 1 percentage 10. 0 plus 1 into 1. 0 plus 1 into 1, 1. 1 percentage 10, 1. Is 1 free? Yes. So there is a possibility of having placed our new data item at location 1. So 80 is placed at location 1. So in this way, you can solve collision using quadratic probing. Linear probing is we check the next location, but quadratic probing is using a polynomial equation like this. If collision occurred, we apply this function. We apply this function by using I square. I square, I may vary from 0 to last location, 0 to size minus 1. So 0 into 0, 1 into 1, 2 into 2, 3 into 3, 4 into 4, etc. If it is free, we store our new data item at that particular location without creating any linked list or any extra memory, which is said to be open addressing. Open addressing. Next is double hashing. Double hashing is an open addressing collision resolution technique in hash tables that uses two hash functions to compute index and step sizes, reducing clustering by making probe sequences data dependent. First hash function is just like division method. If collision occurred, we use second hash function to find offset to store the value in the hash table. So there are two hash functions, hash 1, hash 2, two functions, function 1, function 2. The first function is just like a division method. Division method. In division method, it finds index by dividing the value using table size. So we find index. If there is no collision, the value will be stored there. If there is a collision, then we use a second function, second hash function. The key is fed to the second hash function, p minus key mod p, where p is a prime number which should be taken as smaller than size of hash table. So p should be a prime number. It is a prime number which is less than the size of hash table. Suppose if size is 10, if size is 10, so the prime number below 10 is 7. So 7, p will be 7. So P will be taken as 7 and the new step or offset will be calculated using hash function 2. Let me explain double hashing with an example. For example, if I am going to store 67, 90, 55, 17, 49 in a hash table where the size of hash table is 10, size is 10 means there is a possibility of storing only 10 values. So initially all values are vacant. I'm trying to store 67, 90, 55, 17, 49 in the hash table using double hashing. So two hash functions have to be used. The first hash function. The first hash function is a division method. Division method to store 67. 67 percentage size is 10, so 7 in the place of 7, 67 is stored. Then 90, 90 percentage 10, so the index is 0. In the place of 0, 90 is placed. No collision. So if there is no collision, need not use the second function. Now 55, 55 percentage 10, it is 5. Is 5 filled with any value? No. So 5 is filled with 55. So no collision, no need to use second hash function. Then 17 percentage 10, index is 7. Seventh location is already filled with 67. So now you have to use second hash function. The second hash function. See here, whenever 17 percentage 10 7, there is a collision. Now you have to use second function, second hash function. Second hash function. Second hash function is hash function of 17 is equal to p minus key percentage p. So what is p? 7, because size is 10, p is less than 10, which should be a prime number. So less than 10, 9 is a prime number, no. 8 is a prime number, no. 7 is a prime number, yes. So p is 7. So 7 minus key percentage is 7. 7 minus 17 percentage 7, 3. 7 minus 3, 4. So 4 is not your index. 4 is offset. 4 is offset. At 7, you got a collision. From this location, after 4 positions, you can store your data, which indicates that after this, you can store your data after 4 locations. See, go for 4 steps. 1, 2, 3, 4. 17 is placed at 1. 17 is placed at 1. So therefore, 17 is placed at index 1. So in this way, we can solve collision problem using double hashing method. So linear probing, quadratic probing, double hashing, or open addressing. Open addressing, where it is not going to use any extra space. Whatever the space reserved, only that locations have been used to store data even though there is some collision by searching the next possible location using linear probing, using quadratic probing, using double hashing. But in chaining, it creates a new node, it allocates a new space, new node, and links it to the proper bucket at the end of the linked list. So there is no restriction in the size of linked list. So any number of nodes you can add to a chain, a linked list, but in a array there is a restriction of space. Whatever the space reserved, you cannot increase or you cannot decrease. Whatever the space used, the space reserved, only that space you can use. So which is said to be open addressing.